Hi, junior high. Starting with 169, geometric means with radicals. This is going to go back to finding or using the distance formula, which is something that I always forget and how valuable it can be at times, um, which actually is based off your Pythagorean theorem. So, add our objective is to add multiply radical expressions to find the perimeter in square perimeter and area of shapes with irrational measures. Okay, so right here we have this rectangle. It's kind of sideways. Now, Pythagorean theorem is a squared plus b squared plus, or equals c squared. The distance formula is distance equals the square root of y to second minus minus y1. This is going to be squared plus x1 or x2 minus x1, and this is over here is going to be squared also. So this is like saying this is a squared, this is b squared, and then we square root before we even have to use Pythagorean theorem. But that being said, it is, or it's honestly one of the steps of the Pythagorean theorem, only a little earlier. So I'm gonna go with 6 minus 3, taking that from there, and I'm gonna go, since I took this one first, I have to do it again. 2 minus 5. So you're gonna end up with 3 squared plus negative 3 squared, and both of these square root d. So you're gonna get 9 plus 9, which is 18, so the square root of 18, d equals, so you get that to equal, well, we can take a 9 and a 2 out of this, so you can take a square root of 3 or 9 and get 3 square root 2, because we can't take anything out of that. So this side right here is 3 square root 2. Okay, so now let's find this side. Well, once again, you could do the same thing. You use the distance formula. We would do d equals, and actually, let's go back over down here. Okay, d equals square root of y to the second minus y1 squared plus x to the second minus x1 squared. Okay, now looking at my y's, I'm going to go with 3 minus 1, that's squared, plus, so I started with a 3, so I got to go 5 this time, and that's going to be minus 3, so you should get 2 squared, and 2 squared, plus each other, and that's still under the square root. You're going to get 4 plus 4, which is 8, square root of 8, so that would be, you can take a 4 and a 2 out of that, square root one of them, or square root them both, and you get 2 square root 2. Okay, so this side's 2 square root 2. Now, after doing that, okay, you're like, oh, alright, this, we've done the tough part. So you take 3 square root 2, and you take that times 2 square root 2, and you should get 6 square root 4. Well, can we take the square root of 4? And this is getting me area. So this should end up being 6 times 2, which is 12. So there's my area. That would be part B. A, they're looking for perimeter. Perimeter, well, we'd add these together, so you have 3 square root 2 plus 3 square root 2 plus 2 square root 2 plus 2 square root 2. So you get 6 square root 2, and then 10, end up 10 square root 2 would be your perimeter. Okay, now, this one. You refer to the illustration at right triangle to find the length of the hypotenuse. Okay, so Pythagorean theorem. We got both legs, so we got the square root of 3 plus 1 squared equals c squared. Well, get that back up there, right? Okay, so that's our Pythagorean theorem. So square this, you're going to get 9. Square root of 9 is 3 plus 1 equals c squared. Add them together, you get 4 equals c to the second. Square root both sides, you're going to get c equals 2. Okay, so that's part A. Okay, part B. You're looking at, want to find the perimeter. Well, you'd have 2 plus 1 plus square root of 3. We can combine the 2 and the 1 and get 3 plus square root 3. We cannot go any farther than this because this would have to have a square root 3 to combine these. Okay. So that was B. Okay. Now, practice that. Find the perimeter of each of these. So, this is practice set. I did a couple practice sets for you guys. Find the perimeter and area of each figure in the units. Well, we got to find perimeter. We'd have 3 square root 3 plus 2 square root 3 plus 3 square root 3, because this one would, or this side would be the same as this one, and this one would be the same as that, so plus 2 square root 3. Okay, for us to add, just to emphasize this, I didn't do it probably the best on the first one. You have to have these radicals, the square root of 3 here, square root of 3, square root of 3 is in each one of these. So you can add the numbers in front of them. So you have 3, 5, 8, 10, and then keep your square root 3. This is like having an x with them. You can add x, or you can add things when they have the same variables. Well, that radical is just like one of those. So that would be your perimeter. Okay. Now, just like when you do variables again, when you do the area, trying to be a little more thorough just in case you're still confused. You take your leg times your width here to find the area. Now, the thing is, these are like variables. When we do variables, we add the exponents. Well, we get 6 square root 3 to the second. Well, that would combine this and this to cross out. So it'd just be 6 times 3, which is 18. Okay. And D, what is the perimeter and area of this square? Well, once again, you'd have to use the distance formula. So D, which is square root of y to the second minus y1 squared plus x to the second minus x1 squared. Okay, that being stated, and the nice thing about this, I'm kind of seeing a square here. If you don't see that, you could do the distance formula twice, but I think I'm only going to have to do it once. So you have 4 minus 3, and you have 3 minus 1. So I took from this one minus that, this one minus that, same order. Okay, squared, oh, make sure you can see all that. Okay, this equals D. Okay, so you're going to get 1 squared plus 2 squared. So D equals, and then you square root these. Well, this is 1. 1 plus 4. Well, that'd be the square root of 5. Okay, so to find the perimeter, you'd have square root of 5 plus square root of 5 plus square root of 5 plus square root of 5. Well, this, if I multiplied it by 1, would be the same. 1, 1, 1. Okay, now let's add this together. We have 1, 2, 3, 4. So you'd have 4 square root of 5. Just like on that last one, you have to have whatever's in this radical, treat it like a variable. These variables are all the same, so you can add the numbers in front of them together. That would be your perimeter. Okay, area would be square root of 5 times square root of 5, which would end up getting you, once again, treat these like variables, you'd end up with 5 to the second. Well, square root and to the second power would cross out, and you'd end up with 5. There you go. Nothing too extravagant about this lesson. It is a little confusing because this is something you guys are just kind of getting comfortable with, and hopefully getting a little bit more comfortable with all the time. If you have questions, obviously ask. We will have Zoom class, so should go all right. So we'll talk to you guys during class.